Alright, use a ruler to draw best fit trendline and find the slope using the rise over run method. Trendline is a straight line that shows the pattern in your data, and a good trendline will have as many points above as it has below. So always use a ruler. As many points above, so you want data points above your trendline and you want data points below your trendline. And in order to ensure that, if you're doing this on paper, you want to use a ruler. Absolutely. So let's take our ruler and let's draw our trend line. So I'm going to grab my handy dandy ruler and I'm going to line it up so that I have an equal number of points above and below the line. So notability, if you hold your finger down, you can kind of get a straight line. If I drew my line down here, it would be way below those data points. All the data points would be above. If I drew it right here, all the data points would be below. But if I have it right there on the ruler, let's take a look. I'm going to erase this thing. And yeah, that's looking pretty good. I got 2 points above, 2 points below, 1 data point kind of on the line, kind of above. We have an odd number of data points, so this is as good as we're going to get. I like that. So cool. Step 1 done. Next, we want to find the slope of this trend line. So we're going to identify 2 points that are on the line. Identify 2 points that are on the line, and they cannot be data points. They cannot be your data points that you already found. So these guys, no. And we want to look for a spot where the line intersects the corner of the grid squares. These points are called lattice points, and you should circle them. These points are called lattice points. That might be a new word for you guys. Lattice points. The grid that you're graphing on, that's your lattice. And you should circle them. So, boom, there they are, circled. And those are lattice points. So how do you identify a lattice point? Well, I'm going to do this in blue. I'm going to draw the graph paper grid. So if I'm drawing this graph paper line and I make a cross, then this circle here, it's almost like a crosshair through a scope. You can see it's like a crosshair through a scope, and boom, it lines up perfectly right there. If I placed it right there, you can see that the trend line isn't really passing through, so it's not really on the line. There, I'm on the trend line, but the grid squares don't line up. There, one of the the grid lines lines up, but not the vertical line. And so really the point that works the best is this one right there. And we need 2 of them. Copy, paste. Where's the other one going to go? Well, it's already drawn for us. So let's see how it lines up. Boom. Nice. So that is what we call a lattice point. You want to notice how the line touches the corners of the grid. Why am I being so specific about this? I cannot tell you how many times I've seen students take their data points and then they are trying to find the slope, so they do a little rise over run here. These 2 points, let me do this in red. Oh, this one and this one, they are not on this line. They're not on the line. So you can't, finding that slope doesn't matter. You want to find the slope of your trend line, not between 2 random data points. So once you got those, maybe write them down. We could use the over and up method. Over to 3, up to 40, 3, 40, over to 9, up to 120, 9, 120, 3, 40, and 9, 120. I'm going to remember those and write them down. 3, 40, 9, 120. So these are my 2 data points. Put them in parentheses. That's proper notation. That's my data point number 1. And here's my data point, or not data point, sorry, lattice point. Lattice point number 2. And as always, remember that on the left you got your x, and on the right you got your y. X, y. Boom. So cool, we got our data points. Or, I'm messing up again. Lattice points. There they are. Well, bam. And we're going to find the slope using those 2 points. So let's find the slope using the rise over run method. Rise over run method. What does this method look like? Well, we got to draw a triangle with our lattice points. We got to make sure to count by the correct scale, and we're going to include the units in our answer. So we're going to use the correct, we're going to count by the correct scale, and we are going to be sure to include units in our answer. Okay, so draw a triangle. Okay, you guys know how to do this one. So just, take your 2 points and draw a horizontal line and a vertical line. Well, I can draw my triangle a little bit better than that. There we go. Horizontal line, vertical line. Here's my triangle, guys. This is what I'm talking about. Boom. I got a nice little right triangle here. Perfect. And then I want to count by the correct scale. So what is my scale? So this guy, I'm counting 1, 2, 3, 4. So this scale is counting by ones. So I'm going to count by that amount to figure out my run. 1, 2, 3, 4, 5, 6, 7. My run is 7 noodles. Boom. So remember, I'm thinking about my units every step of the way. And my rise is 1, 2, 3, 4, 5, 6, 7, 8. And if I wrote 8, that would be wrong, because I did not count by the correct scale. That's a mistake everyone's going to make at least once, but make sure you realize what your scale is. So if that first, oh my gosh, I made this graph a little not so great, but whatever. We're just going to move past this. So 10, 10, 10, 10. This graph goes up by tens for each square. So when I'm counting this, I got to count by tens because that's what the scale is by. So always think about your scale. And if I count that, it's 1, 2, 3, 4, 5, 6, 7, 8. But by 10, which makes that 80. Now I'm on the right track. So that's 80 pennies. 80 pennies. So if I'm writing this out, I can write 80 divided by 7. If I use my calculator, let me open this up. Sorry, ladies and gentlemen. 80 divided by, I wish I could do 80 divided by 7 in my head. I just can't. Okay, that's equals 11.4 with a little bit of rounding. And I want to include my units, and the rise was in pennies, and the run was in noodles. So I'm going to say 11.4 pennies per noodle. That word per, this just means divide. So I'm just thinking rise divided by run, and when I'm thinking my units, I'm thinking pennies divided by noodles. So pennies per noodles, and that's how I do it. So I have a slope. Bada bing, bada boom. Just one more thing. So the origin. This trend line goes through the origin, which is point 0, 0, and most always you will be drawing your trend lines through the origin. So a trend line will almost always in this class be drawn through the origin. So ask yourself, if the independent variable is 0, will the dependent variable also always be 0? So let's think about this lab here. So in this lab, if you had a bridge that had 0 noodles, so if your bridge size was 0, then it's not going to hold any pennies. So no matter how many times you run that test, you are always going to get a 0, 0 as a data point, because it's impossible to hold pennies if you don't have any noodles. And so if that's true, that's a really strong data point, so you should force your trend line through the origin. So that's what I want you to think about. If you're always going to get 0, 0 as a data point, then just make sure that trend line goes through that spot. There are some examples where that's not going to happen. Let's look at this lab. So it looks like we have a spring set up to like a little roof or a shelf or something, and then this little gold thing, that's a gold or a brass weight and a brass mass, and they're putting this brass mass on the scale, and it's stretching that spring down. This is called Hooke's law. This person's trying to do a little Hooke's law lab, but they add more, and the string stretches even more. So the independent variable here is the force added to the spring in newtons. Newtons is a measurement of force, and then they're measuring the length of the spring in centimeters. Okay, so we got this lab kind of, we've thought about what they're actually doing, and if you notice, if there is no force, meaning they haven't put any mass on the end of that spring there, the spring is still 3 centimeters long. So that means that if their independent variable is 0, their dependent variable is still 3. So in this case, the graph does not, you're not going to draw your trend line through the origin. You're going to start at 3. So that would be a case where you don't start at the origin. And, for the purposes of just thinking about things, you're not going to, if your data is a trend that goes downward, as I'm just drawing these imaginary data points going with a negative slope, you're obviously not going to bring your trend line through the origin because your line's going the other way. It's missing the origin entirely. So there's a couple cases where your trend line doesn't go through the origin, but in most cases, start at the origin. All right, there we have it.